Many people struggle when choosing an oscilloscope. Should they opt for 8-bit vertical resolution or 12-bit? Today, we will explore the difference between 12-bit and 8-bit oscilloscopes through an experiment. Here are two oscilloscopes with the same bandwidth but slightly different sampling rates and memory depths. However, the experimental method we will use ensures that we focus solely on comparing the core difference in vertical resolution. Using a signal generator to output a 1 kHz, 5 volts sine wave. Input the same sine wave signal. The two waveforms appear almost identical with no noticeable difference. Next, reducing the amplitude to 50 mV. They still look very similar. At this point, do you feel that 12-bit isn't necessary? Now, let's proceed with another experiment. To make observation easier, we switch the input signal to a square wave. Click Run Stop to stop acquisition. Adjust the horizontal time base and vertical scale to zoom in on the waveform. The difference becomes clear. The waveform from the 8-bit oscilloscope shows distinct steps, while the waveform from the 12-bit oscilloscope remains smooth. Why is this? For an oscilloscope, an 8-bit oscilloscope divides the signal into 256 levels in the vertical direction. In contrast, a 12-bit oscilloscope divides the signal into 4096 levels in the vertical direction. Theoretically, the resolution of a 12-bit oscilloscope is 16 times finer than that of an 8-bit oscilloscope. This means that on the screen, a 12-bit oscilloscope can display much finer waveform details, significantly reducing quantization artifacts and producing smoother, more realistic waveforms. The physical resolution of an oscilloscope screen is far lower than the 4096 level precision of a 12-bit oscilloscope, so under normal display conditions, there is no apparent difference between 8-bit and 12-bit oscilloscopes. Only by zooming in on the details of the captured waveform can the difference in vertical resolution be clearly distinguished. An 8-bit oscilloscope is sufficient for most general-purpose measurements. However, in certain scenarios, such as power supply noise analysis, a 12-bit oscilloscope offers clear advantages.